So hi, hello and welcome again. Oliver here, Microbehunter here, and welcome to another Microscopy podcast. I'm uploading this format here both on YouTube and you can of course also listen to the audio-only version. Yeah, there are no important visuals running in the background, so this means if you're just listening to this podcast, you do not have to worry about missing out on anything. Now, if you're new to this channel, to this podcast, yes, I am doing videos, making videos also on hobby microscopy, amateur microscopy, and I like to put things under the microscope and share with my discoveries with you. And today I would like to do the following. I received some comments and some emails that I would like to read it to you, and I would also like to again answer several questions that essentially I was asked. See, these questions are sometimes posted on the live stream, so every week I'm doing a live stream where you can ask questions, and also sometimes questions or comments appear beneath the YouTube videos, and yeah, some of them are quite interesting that I would like to share with the community. I'm not always able to answer all of the questions in the comments section. This would take quite a bit of time. I basically have to be kind of selective about this. Sometimes members of the community are answering those questions. It's very nice as well. But I decided, well, why not kind of make an audio version of the whole thing, and then yeah, basically I'm able to answer them in that way. I would like to first of all start off by reading out two comments that I got. Basically, there are no questions here, but I think they were kind of quite nice, and for this reason, I would like to share them with you. And I'm not going to say any names, and these comments were publicly visible, so I'm not basically disclosing anyone here. And here we go. Yeah, I've always been interested in looking through microscopes since I was quite young. I finally got my first microscope at age 68. I wasted a lot of time. Your videos helped me get a lot of that time back by showing the proper way to do things and not wasting any more time learning the hard way. You're a great teacher, and you keep the hobby interesting. I even have slime molds growing. Thanks a lot. And one of the reasons why I'm reading out these not questions, but these comments is because I also would like to say thank you, of course. Yeah, I would like to say thank you back for the positive encouragement to keep on making videos and to keep on promoting hobby microscopy. There's a reason why I actually do that. As a biology teacher, sometimes I feel that sometimes the academic approach to biology can sometimes be a little bit dry. The syllabi to cover, you've got assessment, and sometimes in a school context, you cannot do the exploration to the extent that I like to do it, simply because we're restrained time-wise and so on. And for this reason, I'm happy that maybe this YouTube channel and this podcast kind of helps recapture this original, how do you call this? I'm missing the words a little bit. This original love for nature and fascination for observation, right? Yeah, there is another comment here that I also would like to read with you, for you. That is so interesting. So this was a response to one of the videos. That is so interesting to know where you found the tardigrade. That's a water bear, right? In the future to come, that is one of the many projects I like to do. Thank you so much for every one of your videos. In most of your videos are most of the projects like to do being new to the hobby. At the moment, I'm just learning about calibrating the microscope. Once that I've done this, I will move on making dark field filter. That is basically the thing of another video. I have so many things to do that I have learned from you that I'm looking so much to get started. Thank you ever so much. Please carry on with the videos. Thank you very much. That's actually also one of the reasons why I'm making videos and podcasts and YouTube shorts and so on. This is because I would like to encourage people to pick up that hobby, that's essentially creating a little bit of a community, as I say, in a crazy time that we're living right now. Sometimes it's nice to have a little sphere, maybe a little bubble for ourselves, where essentially we can follow our passions and our interests, and be at least for a couple of minutes per day, look through the microscope and forget about the crazy world around us. Okay, I digress. Okay, so what I'm going to do now is I'm going to read through a couple of the questions that I've got, and I would like to take you. I will give you my take on it. That's the way you say it. And some of the questions are going to be kind of specific, others less so. Yeah, let's just get started. So this the first question is we never see you wearing gloves while collecting samples or handling them. Why is that? So the question refers to when I'm handling samples and collecting samples for microscopy. I go to a pond, pull out a water sample and take it home and put it under the microscope. And I never wear gloves. That's correct. Why is that? Well, short answer is because the samples that I'm handling are not dangerous. I would not take water from contaminated water sources like sewage water. I would never do that. That indeed would be a health hazard. So the water samples that I'm taking, I mean, you theoretically could go in there and actually swim. I mean, some of the ponds and lakes that I take the water from, people are swimming. So it is not really a health hazard. Yeah? However, I do agree that you have to be sometimes a little bit careful. So, for example, I would never essentially deliberately spoil some food and meat. For example, specifically meat is a problem because those bacteria that can grow there potentially could maybe also grow on human beings. And then with those, I would be more careful, right? But I don't do that. So if you directly collect samples from nature, or for example, I mean, a very easy one, a moss sample, you grab some moss and you basically rinse out the moss to find some of those water bears, tardigrades. I mean, that's not a problem. I mean, when you're barefoot, you're walking on grass, you're walking on moss. Yeah. So we are exposed to these things already. And if you're not growing the microorganisms or increasing their concentrations, but if you just take them from a natural source, then generally I do not consider this a big problem. Now, sometimes you hear online people, this is a traditional method, they do so-called a hay infusion. What you do is you take dry grass, and you put water on top of it and you let it stand, and then you have essentially bacteria growing in there, which you might want to put under the microscope. And this is actually something where I would be a little bit careful, because here you are increasing the concentration quite of bacteria, specifically quite a bit. And I would be a little bit careful, because if you are spilling that and if you've got maybe some an open wound somewhere in your skin, you don't want to get that in there, right? But generally, if you do not enrich the bacteria, if you don't grow them, the microorganisms, then essentially, it's just from a natural source. So essentially, same thing. Spoiled food, for example. I mean, same thing contains a lot of bacteria as well. I would, for example, be way more careful in handling raw chicken, and because there's salmonella on there, and that is known to actually cause salmonella infection. So what I'm saying here is I'm not saying that it's not dangerous. Generally not dangerous, and I'm also not saying it's generally safe. I'm basically saying it depends. And the samples that I'm using here are generally safe, because I don't want to put myself into danger, right? So there is no need, in my case, to wear gloves. So the next one is also kind of specific, and I also need to explain a little bit of why this question was asked. How do you dechlorinate tap water? Are standard fish tank dechlorinating solutions enough? So what does this have to do with microscopy, especially when you want to grow water fleas, for example, Daphnia or other water microorganisms, and I grow them in a jar, for example, and when the water evaporates, you want to add some more water, right? Normally you would like to use pond water, but you can use tap water as well, only if you add very little, bit by bit, but it should be free of chlorine. Yeah, and in some countries the tap water is chlorinated, and this is not good, right? Obviously. So what you can do is you can let the tap water stand open for several days, and this will evaporate the chlorine. However, I've read now, after a little bit of research, that sometimes they've added a form of chlorine that does not evaporate. And in this case, you have to use some kind of dechlorination solutions. Now, I have never used them before, but I would say that if they're safe for the fish, right, if it kind of removes the chlorine from so that you can use it for fish, then I don't see why it shouldn't also work for other water microorganisms or water organisms in general, right? Um, but my philosophy is a little bit different. Why this complicated way? Just use some bottled drinking water, right? I think that's the easiest way, and then you basically can be sure that it's going to work fine. Yeah. So that's simply some advice for growing your own water organisms here. So the next one is again a little bit more technical here. And this is, I have a Vivor double boom microscope, and whenever I try to use the finer adjustment knob or the continuous zoom, the vision becomes blurry. Any ideas? So this is a usage question for a stereo microscope. And what you do is the following. You have to zoom in all the way. You take, a flat piece of paper with some writing on it, and you zoom in all the way with a stereo microscope. And you basically, what you do is you focus, right? And then what you do is you zoom out, and then it should actually maintain the focus. And if it loses the focus, then what you do is you try to adjust the focus with the eyepieces, because the eyepieces have so-called a diopter adjustment, and the diopter adjustment is there to balance out different vision of the left and the right eye. But the diopter adjustment can also be used to adjust the focus. So what you want is you want to make sure that basically the image stays in focus when you zoom in and zoom out. And if it kind of loses the focus, then you might want to adjust it also with a diopter adjustment of the eyepieces. Yeah. So this is specifically of importance if you have a phototube connected, because sometimes the phototube, when you zoom in and zoom out, loses the focus, and for this reason you have to make sure that it stays in focus by then adjusting also the focus of the phototube. Okay, so but this one was not a phototube question, but more a question of zooming. Generally, a little bit losing the zoom, losing the focus a little bit is generally considered to be okay. So the next one. The next one is also a slightly more technical one. My answer is going to surprise you. I love your videos. It's opened my eyes to a whole different world. Well, that's supposed to be like that, okay? But it goes on here. Can you recommend a quality centrifuge? Can I recommend a quality centrifuge? What are centrifuges? Centrifuges are devices, laboratory devices that spin very quickly, and in a test tube you can then basically separate solid material from a liquid suspension, right? And you can do that, for example, when you take pond water and you would like to collect the algae that are in the water, and then you put it into a centrifuge and then you spin it for a couple of minutes, and then on the bottom of the test tube or of the centrifuge tube, then you can collect the algae. So it's a way of concentrating the substance. And the question here is a common one. Can you recommend a quality centrifuge, a quality microscope, a quality whatever? And the short answer is what do you mean with quality? Right? That's a difficult question, if not impossible to answer. What's quality? The prices go up all the way to, I don't know, nearly endless. You're probably, as a hobbyist, you probably don't want that anyway. It would be a waste of money. But centrifuges can be already bought for fairly low price, and they got to do their job really. And essentially, even a slow spinning centrifuge, which spins maybe around 4,000 times per minute, is going to be enough for you to collect water life. And those ultra centrifuges that spin very quickly are usually there for concentrating DNA. That's not something that we normally need as hobby microscopists. So my general suggestion is get yourself a centrifuge that is able to accept the standard size centrifuge tubes, and around a speed of around 4,000 times is going to be fine. I've bought mine for, I remember this was a couple of years ago already, for less than 70 euros or 70 US dollars. It was on eBay or on Amazon, I don't quite remember. And it worked fine. It's not the best model, but what does best even mean? It does its job, it works, and it's going to be fine. So generally, my suggestion is you have to define a little bit for yourself, what does quality mean, and does it do the job, right, for you? And then I would say it's a more question not about the centrifuge, but about your specifications. Yeah, what are your expectations? Yeah? Next question is, could these worms' movement be stopped, under quotation marks, stopped using flash photography? Kind regards. So this refers to now to nematode worms, and I'm growing them in a jar with vinegar, called vinegar eels, these nematode worms, and they're moving around quite rapidly. And the question is now, is it possible to kind of freeze their motion by using a flash? This actually does exist. It's called microflashing. It's microflashing, and theoretically that would be possible. However, you do need some kind of a specific setup for that. And generally, I would say it's probably not necessary, and there are probably also easier and better ways on how you can do that. One possibility would be is actually to take a video of the worms and then essentially take out one individual frame. However, even in this case, it's very often like this that there's going to be something called motion blur. So that means, even then you're not really going to freeze the motion of the worms, but actually it's still blurry. So video would be, however, one possible approach, but there are two other ways what you can do. The second possibility is you limit their movement by really using very little liquid. So the worm, or whatever microorganism or organism you want to look at, is sandwiched between the cover glass and the microscope slide. And this inhibits their movement. And this basically is actually a very good way of kind of making them slowing them down enough so that you can take a proper video or a proper picture. And another possibility that I suggest, if you do not want to limit their movement but still slow them down, is to make a 2% methyl cellulose solution. I made separate videos about this. Methyl cellulose is a powder that you can buy. It's, I think, used in food production to make substances thicker. And what you do is you take, essentially 2 grams of methyl cellulose, and you add 100 milliliters of water. That gives you 2%. I mean, 100 milliliters is way too much, honestly. So you're going to be able to use this for the rest of, I don't know, for the next 100 years maybe. But if you take, if you make a 2% methyl cellulose solution, and this is a very thick liquid, a highly viscous liquid, and you can mix that with your water sample, and this slows down the microorganisms and the worms significantly. So essentially, if you take the same amount of methyl cellulose solution with the same amount of water sample, and it gives you a 1% solution, this is perfectly fine. So you don't make too much. I think only made 10 milliliters of it, and it lasts for a very long time. You might want to still be a little careful that it does not turn moldy. So you might have to make a fresh solution every now and then. So essentially, this is another suggestion that I have is that you essentially try these methods to slowing them down. Next question. So I often see microscopy videos with a bright blue background. How is this achieved? And this is this polarized light or some other technique. Especially also in the videos that I'm making, there are quite a lot of colors there, more colors than what you probably normally would see. And the reason is because the blue background is achieved by a technique called DIC, differential interference contrast microscopy. It's quite a long term. And that is a specialized technique which does indeed use polarized light. And which gives quite nice and impressive images, colorful images. These are not the natural colors, however, right? However, the issue is it's kind of expensive, and not many companies actually offer DIC techniques, equipment. So this is something where you have to go a little bit, you have to look around, but it might not be necessary, because what you can do is you can use homemade filters that are also resulting in surprisingly impressive color plays, and that basically means that you make your own filters. I've made several videos, and instructions are plentiful on how to do that. Lots of trial and error. You have to get the filter dimensions correct, but this also adds quite a bit of color to your microscopic images and videos. So this DSC does use polarized light, but it is not the regular it's not regular polarization microscopy. I just want to also clarify this. So that is basically the reason of why many videos are colorful. So next one. The next one is another one. It's a longer one. Oliver, would you consider doing a video based on identifying ciliates, flagellates, and other microbes based on the type of movement? I find few references to movement, as many are identified as dead or stained organisms, but I enjoy watching them alive on a slide. This might be useful to other amateurs who enjoy watching pond microbes. That's an interesting one. Basically, the thing is the following. If you have a picture of a ciliate or flagellate or any microorganism, of course, it's not moving around. Right? It's a picture, right? And is it possible to kind of identify them just based on their movement? And I think maybe that's going to prove to be a little bit difficult because what are you actually looking for, right? I mean, ciliates and flagellates and so on. I mean, they're moving around, and generally it's the shape and the presence of either cilia or flagella in this case that is important. So normally, for identification purposes, what we do is we just look at basically how they look like under the microscope. Yeah? And strictly speaking, when you talk about identification, it depends a little bit on the level that you want to identify them on. So to what degree? I mean, you can say, okay, it's a ciliate, right? It's paramecium is a ciliate. Vorticella is a ciliate. So it's kind of a category. They kind of look different, but they have certain features that are similar. But you can basically look at them and you can give them a name, or you can identify them. But if you want to go down, possibly down to the species level, then things start to become a little bit more difficult, right? Because then you have to look at details that might not be visible directly under the light microscope, and you have to use traditionally some kind of staining techniques. So for example, in the case of certain ciliates, paramecium and so on, what they have done is so-called silver staining, and this kind of makes the flagella, not the cilia, not the flagella, the cilia visible, right? The cilia of the paramecium visible, and the way that they're arranged, then you are able to kind of categorize them and identify them. And in the case of flagellates, they have one whip-like flagella extension. That's Euglena, for example, is one of those. And if you just see this flagellum, then you know it's a flagellate, right? And then you have to essentially continue looking for other features. But the biodiversity is so high that I think it's going to be difficult to really identify them all the way down to the species level without doing some kind of a DNA analysis, right? And it depends also to a certain extent, or to a large extent also, in which organism you're looking at, because for different organisms you might essentially need different techniques to identify them. Yeah. So what I'm trying to say here is that a movement probably might not be the most suitable characteristic here, because I don't know exactly what are you looking for here. I mean, and ciliates and flagellates you can actually identify already by looking at them. So so that's a little bit the thing here. And I would probably recommend that. Not recommend, but in many cases it's not even necessary to identify them all the way down to maybe a species level, and then things are going to become complicated then anyway. So next question, and that's already one of the last questions here. Where do you get your paramecium and amoeba? I have tried river water, but I find only worms. The thing is the following. This kind of ties in a little bit now with the first question. You got what I do is I'm enriching them. Many water samples actually contain water microorganisms. If you want to find amoeba, a good source is if you find old decomposing wood, like for example from a branch, often covered with lichens and maybe a little bit of moss. Take this branch and put it into a jar of water. So basically that half of the stick, wooden stick, is submerged in water and the other half is not. The water is going to be taken up into the wood. And what you want to do is you want to then, after a couple of days, scratch off a little bit from the wood and put it under the microscope. And I've generally found, also amoeba in there. quite a few, because they're kind of crawling around on the wooden stick and breaking it down and decomposing it. When you want to find paramecium, for example, and these are water organisms, and I found them also not only on the bottom of certain ponds, but I've also found them in certain moss samples, provided the moss was always moist. They're not able to survive drying out. And then if you really want to get a very high concentration of those, then you have to be a little bit, do some called enrichment. And what you do is you take a wheat grain, a cereal grain, and you crush it between 2 spoons, so that it still stays together as one unit, but it's kind of broken open. And you add this to the water sample, and then you have to wait 3, 4, 5 days, a week maybe. And then you take out the wheat grain and you dip it on a microscope slide, and then you put the wheat grain back. The wheat grain by that time will already look very, how shall I say, disgusting and slimy. And in many cases, it will be full of paramecium, ciliates, unless you have some water crustaceans in the water sample which eat them. Generally, I found always a lot of these in the crushed wheat grain. This, however, means that you are growing microorganisms, and here you have to be again a little bit careful. I mean, while I am not wearing gloves, I make sure that everything's clean. So if you take the tweezers and you basically take out the wheat grain, which contains a lot of bacteria and these paramecia as well, then afterwards you probably want to disinfect the tweezers with alcohol and wash it properly, because sometimes the tweezers that I'm using are quite pointed, and if you kind of hurt yourself, then actually you might possibly get an infection. Yeah? So this is something just as a precaution. Yeah. So for this reason, I would say general hygienics are kind of generally good to keep. I'm not saying it's extremely dangerous, but anytime when you're growing unknown microorganisms, you should take certain precautions. Okay, and if you keep the concentration of oxygen high enough, then those paramecium are going to readily multiply as well, and then they're going to eat the bacteria, and they're going to keep the bacterial count down. So this is something that's also important to keep this balance in the food chain. Yeah. So basically, river water. Don't just take the river water, but take some sediment from the bottom of the river. Yeah, and add a small wheat grain. And then wait a couple of days and then put the wheat grain, a small amount of that, under the microscope, and then maybe you're going to be lucky. Okay. Having said that, sometimes I also was not lucky, and then I found out too late that there were also some water crustaceans in my water sample, and basically they've been eating up the whatever microorganisms that multiplied were eaten up immediately again by the water fleas, the Daphnia and the copepods and the ostracods, and I don't know what they're all called, right? Yeah. So I'm actually finished with the how do you say the questions here, but I do want to add a couple of additional comments at the end. You're now basically listening to this audio version, which is, as I mentioned already, also published in my YouTube channel. But I have a second YouTube channel as well. It's with a similar name. It's called Microbehunter Microscopy. There are links, of course, down below. But this second YouTube channel is a little bit more technical. We're talking about microscope optics. I'm doing some microscope reviews and so on. And I would like to simply encourage you and invite you to also visit that channel and maybe also to subscribe to it. That would be kind of nice. That's an important support. I also have collected on Amazon. I've collected some microscopy products. There's an affiliate shop. So if you also want to support the channel, if you have a look at the shop there as well. I have to also say as a disclaimer, I do earn a little bit of a commission, but that is also kind of important so to keep the channels going and alive. Otherwise, if you have any specific questions that you would like me to address, please do feel free to write comments, at least if you're watching the YouTube version of this podcast, and there's a possibility to post comments, of course, beneath it. Yeah. Otherwise, I think I'm just going to call it a day today, and I wish you all the best, and happy microbe hunting as always, and hope to see you again soon. Bye bye.